All right, guys. In 2.5, we're going to be using the formula. And so when we are calculating, just to review, when we're calculating interest for 1 year or less, then we would use this simple interest formula. Then we would use I equals P times RT. When we're calculating this is nice when it's when it's simple interest. Calculating compound, we're going to use this formula. So A equals P, parentheses 1 plus R divided by N to the N times T. Now let's talk about this. A will give us our account total. This here is your initial or starting. Initial is another word for starting deposit. R is your interest rate as a decimal. T is years. So compound interest is a formula that we're going to want to use when it's several years. Okay, so this is more than 1 year. It makes this much faster. And then N is how often it's compounded. So let's review from 2.4. If it says semi-annual, then N equals 2. If it says quarterly, then N equals 4. If it says monthly, then N equals 12. If it says weekly, then N equals 52. And daily, N equals 365. Those are the most common. Annually would just be 1. I didn't include that because that's silly to use this formula if it's 1. But if it's annually, then N equals 1 because annual would just mean once a year. The only other, so this formula is for compound interest. The only other formula you need in this section is APY. Okay, APY represents your annual percentage yield. And they also talk about APR. And you'll see that on commercials for car, like the interest you're going to pay on a car, or the interest you're going to pay on a credit card. This is your annual percentage rate. Now to calculate APY, you simply take 1 plus your rate divided by how often you're compounding it to N minus 1. And I say it's that simple because when you have a formula, you're just going to plug the numbers into your formula. So we're going to practice some of these problems. On here, again, you can print my notes so that you have these. Print your notes so you have these to do your homework. So here we go. And I'm going to use a different highlighter this time. All right, so and we're going to be using our calculator, or you can use Desmos, but I get a big glare when I use Desmos on this screen. So again, remember, compound interest formula is A equals P times 1 plus my rate divided by N to the N times T. So in number 1, here is I open an account for P dollars. There's the interest, compounded quarterly. What's my ending balance after 1 year? So my account equals, I don't know, P dollars. 1 plus my rate as a decimal divided by N represents how often you compounded it. That right there is N. And says it's quarterly. That would be 4. To the 4 times 1. And now we're going to simplify. We're going to enter this right here in the calculator. So we're going to enter in calculator, where Desmos does it beautifully. So let me clear this. Parentheses 1 plus 0.0211 divided by 4 to the 4th power, right? 4 times 1 is 4. And I get 1.021. So I now have A equals 1.0213. I'm going to round. This 6 makes the 2 a 3. And I still have the letter P. And so that is my answer. Next one. Jeff deposits $2,300 at 1.3 interest compounded weekly. What is his balance after 1 year? So here we go. Account equals 2,300, parentheses 1 plus our rate, so 0.0113. Weekly, remember that's N equals 52, so 52. To the, it'll be N times the number of years, which in this case, again, is the number 1. So, using our calculator, 2,300 times 1 plus our rate, so 0.0113, divided by 52 weeks, to the, that's my exponent button, 52 times 1 is 52. And I get 23, 26, and 13 cents. Next one. Nancy has 4,111. Here's her interest rate, compounded monthly. What's her balance after 2 years? So that's all the things that are important, right? This is P, this is R, this is N, this is T. So A equals P times 1 plus our rate divided by N, which in this case monthly, so there's 12 months in a year, to the, I have 12 times the number of years, which is 2. So let's enter that in our calculator. 4123, parentheses, 1 plus our rate divided by, we're doing this monthly, to that 12 times 2 is 24. So I get $4,199. Can't really see that, huh? $4,199.88. Now, you can pause and then try number 4, try number 5, and then check your work with me, okay? So, next one. He has a balance of $19,000. Here's my interest, compounded daily. What's the balance after 3 years if no deposits or withdrawals made? And so he wants to know balance and how much interest does he earn. So let's first find my balance. So I have $19,211.34 times 1 plus my rate divided by daily would be $365. In parentheses, I have 365 times the number of years. Okay, so let's enter that in my calculator. 19 to 11.34, parentheses 1 plus 0.011, divided by 365 to the, and I have to put this exponent in parentheses because I don't know what 365 times 3 is. So make sure your exponent, if there's more than one number, is in parentheses. So 365 times 3. Okay, so I have $19,855.88. So that's my balance. How much interest did he earn? Well, she has $19,855.88 minus what she started with, and that'll tell you how much interest she earned. So I'm going to take this number and I'm going to subtract, I'm going to re-enter it, $19,855.88 minus what we started with, which was $19,211.34. and she had the amount of interest she earned was $644.54. So you should have 2 answers for that one because they asked for 2 pieces. Next one, if I invest $10,000 at 3 hourly 5 years. So let's go back to how many hours are in a day. 24 hours times 365 days would give me 8,760 hours in a year. Okay, so I'm now going to enter this. I have what's in my account. I'm running out of spice here. So A equals she invested $10,000. 1 plus my rate divided by 8,760. My exponent is 8,760 times 5. So that's what I'm going to enter. So 10,000 parentheses 1 plus 0.038 divided by 8,760 to the 8,760 times 5. Wow, she has $12,092.50 in her account. It's a lot of money. All right, next one. She invests $22,000 for 4 years at that interest rate compounded monthly. So that's 1 plus 0.0155 divided by the number of months, to the months times 4 years. So enter that in your calculator, and I get a total of $23,778.61. That's her total. If you subtract what she has now, well, if you take what she has now and subtract what she put in, the difference is she earned $1,428.61. All right, so now let's move on to some different problems. I'm not going to do some of these because it's just repeated over and over and over. So let's go ahead and calculate. It says, go ahead, what is the annual APY? Remember, APY equals parentheses 1 plus the rate divided by n to the nth power minus 1. So in this case, it would be 1 plus 0.018 divided by n, and it says daily, so 365. So then I would do that to the 365th power and then minus 1. So in my calculator, I'm starting with 1 plus 0.018 divided by 365 to the 365 power. I'm going to enter and then subtract 1. I get 0.0182. So I'm going to make that a percent, so 1.82%. Okay, so I'm going to skip 8 and move on to 9. What is the APY here as well? So I'm going to do 1 plus my rate, 0.0166, and this is daily, so 365. So to the 365 minus 1. So I'm just going to enter that into my calculator. 1 plus 0.0166 divided by 365 to the 365th power minus 1. And I get 0.01674. So as a percent, that'd be 1.67. So notice it's very similar. 10 and 11 are the same type of problems over and over and over. So I think we don't need to do that all over again. So we're going to move on. So we're going to talk about the effects of everything. So she has created this formula, and it wants to talk about if Q is increased. Well, in this formula, Q is your interest rate. So what do you think would happen as our interest rate? Do you think we're going to make more money or less money if we have a greater interest rate? The answer should be an increase. The greater the interest rate at our bank, the more money we'll make. Okay? If K is decreased, K is how often compounded. Well, if you've noticed, the more often we compound it, the more money we make. So if this is getting smaller, then the amount in our account will decrease. So the more often the bank calculates our interest, the better. If B is increased, then what do you think is going to happen to the bank or to our balance? It'll increase. The more time that goes by, the more money. More time, more money. Is it possible that M will ever be greater than X? No, right? Because you're multiplying by a number greater than 1. We're going to skip E. All right, so in part 13, they're trying to get us to understand compounding exponentially. So this is the last problem I'm going to do. How many seconds are in an hour? Okay, well, there are 60 seconds in 1 minute. And there are 60 minutes in 1 hour. So 60 times 60, there are 3,600 seconds in 1 hour. How many seconds are in a day? Well, that would be 3,600 seconds. This is that's per hour. And there are 24 hours in the day, so that would be 86,400. How many seconds are in a year? Well, you would take 86,400 times 365 days, and that would give me 31,536,000 seconds in a year. So how much interest does $1 million earn in 1 year at 6.3% interest compounded every second? So that would be 1 million. 1 plus our rate divided by 31,536, 1, 2, 3. And our exponent would be 31,536. So if we enter that in our calculator, how much would I earn? My account total, so that means I would have earned in interest over $65,000 in just interest, which is why it's beneficial. The more you have in your bank, the more interest you're going to earn. So how much would I earn under simple interest? Simple interest is just principal times our rate times 1. So if I multiply that, I only get $63,000. So how much more? $65,002.76 minus the $63,000. So this is if the bank compounds it every second. This is if the bank only calculates it once. So the difference is you are making $2,002.76 more. So the more often they compound it, the more money you'll make. And that concludes that lesson.